All right, so here we are, chapter 4. Before we jump into this, I do want to talk a little bit about my fundraiser. It's just got a few days left, and I literally do not have enough people to give away these prizes to. So if you give even $5, you will basically win one of these things from Vercel or Mux or Cloud Cannon. It's for childhood cancer. I just did a long video yesterday with somebody I've followed forever online, so it was really cool to get to chat with him. But his name's Stephen Hackett. He's a co-founder of a podcast network that's kind of spearheading this initiative with St. Jude. But really the big push is this next 7 years. They're trying to spread not just their research and a lot of their like knowledge freely, which they've done forever, but they're trying to actually get real resources in the hands. So chemotherapy, drugs, all this kind of stuff in the hands of children who don't have access to it around the world. So they've started with 5 countries right now, and they're hoping to expand that to 70 by the end of 7 years. So all of this is done on the backs of donations from regular people like you and me. So if you'd love to give, I would love to have you join me. You all are always so generous every year. I think this year has been really hard for a lot of people donating, and a lot of that's just the instability in the world, and I totally understand that. But if you've got $5, I'd love for you to join me. Last year we raised about $3,600. I was super ambitious this year, and I probably should have paid attention more to the donation landscape, but I would love to at least have enough to give away all these items I have. So I have stuff from Cloud Cannon, which they've got a lot of really cool stuff coming out with Astro actually coming up soon. Console Ninja, which I basically can't code without. Dracula, which is a theme for your terminal and editor and all that kind of stuff. Git Tower, which helps you visualize Git and like a GUI editor instead of having to use the CLI. My own Astro course, Mux, which is a video streaming platform. I just did a video on them. Neon, which is a scalable database. Coca.js, which helps you run stuff live. We'll actually use it today. And like JavaScript live and actually see the values. Wallaby does the same thing, but for tests. And then Vercel, you can use it to host things. Obviously here you've got $100 of credits for 6 months. And then Warp gives you a year's worth of their pro plan, which is super helpful. It helps basically bring like this agent to the terminal so we have this rich interaction with an agent. It's like Claude. It's like a lot of the autocomplete tools you can install yourself, but it comes out of the box kind of ready to go. You can build custom workflows, share it with your team. There's a lot of cool stuff. I used to work for Warp as a contractor, so I'm a big fan of them. But yeah. All right. Well, hopefully audio is fine because I haven't seen anything in a second. So let's go ahead and jump straight into the book on data objects and arrays. And I do need to be maybe a little faster today, which doesn't help that I started weird. But what I want to do is what I meant to do last time, which is to start by looking at the summary. So we can kind of see where we're headed. We'll walk through this. And then if you have questions or things like that, let me know, but we'll just jump straight in. So, okay. Objects and arrays provide ways to group several values into a single value. This allows us to put a bunch of related things in a bag and run around with the bag instead of wrapping our arms all around the individual things and trying to hold them separately. All right. I like the analogy. I haven't read this chapter yet. One of these days I need to start reading them ahead of time, but right now, since we're kind of at the basic structures and stuff, I've just been doing it live with you. Most values in JavaScript have properties, with the exception being null and undefined. We've looked at these values before. Properties are accessed using value.prop or value prop, like that with the brackets. We'll talk about the difference of those, I'm sure, as we go. Objects tend to use names for the properties and store more or less a fixed set of them. Arrays, on the other hand, usually contain varying amounts of conceptually identical values and use numbers starting from 0 as the names of their properties. If that's confusing, basically we're talking about two things, objects and arrays. Objects, you name the things inside. Arrays, you just count them by their index, and they're 0 indexed. All right, awesome. So you know the song. Okay, yeah, I don't know. It's just whatever epidemic sound is playing right now. There are some named properties in arrays, such as length and a number of methods. We'll talk about properties and methods. We've talked a little bit about them already, but basically these are items that live on arrays or numbers or strings or any value, basically. You can also create your own methods or your own properties as well. Methods are functions that live in properties and usually act on the value of which they are property. You can iterate over arrays using a special kind of for loop. And there's a bunch of cool methods we get with arrays and objects that let us interact with them. All right, so we're looking at objects and arrays. So let's, first of all, maybe think a little bit just about like why we'd want extra structured things. So this is our little tester thing we did from last time. I don't know what's going on here. Let's see if we can run, let's run Quokka on this. Okay, cool. This is what actually one of those things I'm giving away. Oh, maybe I have to actually pull that up. Do I have to pull it up? Maybe, I don't know. Okay, anyhow, this is one of those things we looked at. So if I come over here and we have something like name equals Chris, and let's say that this is like a student or something like that. And then I might say const, I don't know. Then I say, well, I want to have like the age of this person. So we'll say like, oh, this person's 12. And then maybe I want to have like which classes they're a part of. So I could have const class 1 equals like geography or something. And then let's say class 2. So const class 2 equals math. All right, mathematics, whatever. So here we've got 2 classes, an age, and then the name of the student. Well, this is great. However, I want to group all this, right? I don't want to have to like hold these individual values. That's what they were talking about, putting them together in a bag. So what we can do is take all of these and basically assign them to an object. And I think that's probably where we'll start, because that's what they were saying a second ago. So I could say like student, and there's obviously more things we can do here. But then I would just say name, age. Let's actually move all these like this. And then at the end of this, down here, I'd close off this object. So we're going to name it, and then we're going to assign it to this object, which we define with these curly brackets. Now, obviously, you see this isn't working, and that's because we do actually structure this a little bit differently. We assign it with this colon, and then we just have commas in between each of these things, and I don't have to actually add const in all these. The const is done once, and then these are essentially the values inside of it. Now, notice there are different types of values, right? So we've got a string here, we've got a number here, we've got 2 strings here. We could have like is smart, if I can spell smart, and we could say like false, okay, or true or whatever. So we could have Booleans, we could have strings, we could have numbers. Those are the kinds of things we looked at. In fact, we can even have actual like functions in here as well. So I could say like, let's name this like, I don't know, does stuff, all right? Whatever I call this, then we like fire off, console.log. Hi, I'm doing stuff. All right. So usually they act on the actual object up here, but they don't have to. So what I can do is come down here and I can reference any of these by referencing the parent name here, student. I'm getting ahead of the book. I don't know why I just read it to you, but here we go. And I can reference it with a dot. This dot notation lets me like pick off the individual values inside of there. And you can see how much more helpful this is than listing all these individually, a name, an age, that kind of thing. So if we come here to student, I could say age, and then I get the age of the student. And because I have Quokka running, I think it'll tell me. Maybe not. Maybe I have to console log it. Console.log student.age. Okay, cool. So I get that. Now, because I have this does stuff, I could also come in here with student, and I can reference an actual function. Now, whenever a function lives on an object, we call it a method. There's a little bit more complexity there that maybe they'll get into, but this is the pre-lesson before we read the lesson because I'm not sure why. So what we're going to do is look at does stuff, and we can call that function like this. So this actually calls the function directly here. And notice it says, hey, I'm doing stuff. I don't know why it's not showing here, but it's actually running right here, and it's doing whatever this function is. Now you can see here I have an arrow function. That's how I've happened to do this. Now, if that's confusing, remember we can also use the function keyword, right? And we've talked about that as well. If I can make this work, there we go. And we are doing stuff here and we like it. Okay, so that's another way. And now it says I'm doing stuff as well. And here we're console logging it up here. So we can use an arrow function. We can't use a function expression like this where you give it a constant. So it has to be either an arrow function or a function declaration. But you can reference these, and it's called a method. And so you reference a method the same way you reference any property here on an object. The dot notation, except in this case, you have to actually call it. So you call it, you invoke it by using this this method right here. And the reason we do this is because sometimes you want to call stuff in. So like, remember, we might have things like a placeholder, these properties. So I'd have like a name, and this is going to be the person's name. And so inside here, this is the name right here, and we'd interpolate the string like this. We looked at this. I know, especially if you're new to JavaScript, some of this can feel like gobbledygook. The important thing right now is the concept. You'll figure out the syntax as you use it. But because we can pass items in like this, this is why we invoke functions like this, so I can pass that in. So I'd say like Joe, all right? And then now it says, hi, I'm doing stuff, Joe, right? So it's going to actually grab this value, this argument that I passed in down here, and pass it in. When you don't have an argument, you still pass it through like this. And that way we can see here it's a function. I'm just not passing anything to it. I'm not passing any arguments to it. Now I need to get rid of all this. Okay, so that's the pre-lesson. Let's actually see what they want to say. All right. All right, numbers, booleans, and strings are the atoms from which the data structures are built. We've already seen that. Like when I created that object, we had strings and numbers and booleans, right? But oftentimes you want to group them together. That's what objects allow us to do. So the programs we built so far have been limited by the fact that they were operating only on these kind of simple data types. After learning the basics of data structure in this chapter, you'll know enough to start writing useful programs. And objects really kind of open up the game. So I'm excited that we get to actually start to look at them. And in fact, in some sense, everything in JavaScript is an object, which we'll see. All right, every now and then, usually between 8 p.m. and 10 p.m., Jacques finds himself transforming into a furry rodent. What's going on? I have no idea. Okay, so we're talking about some random squirrel. All right, we're going to skip past that. We're going to count my pre-lesson as the lesson. All right. They're telling a story of like he's grouping lots of things. Okay. To work with chunks of digital data, we first have to find ways to represent. I was like, am I in an alternate reality here? Why are we reading about squirrels? I don't know. I should have read it, I suppose, ahead of time. We could get creative with strings. Say, for example, we want to represent a collection of numbers 2, 3, 5, 7, and 11. So you can get creative with strings like this, group them together. Or we could also use this other thing we haven't looked at, which is arrays. Curly brackets define an object. These straight brackets, whatever they're called, define arrays. So this is how we define arrays. And notice they're all the same type of stuff. They don't have to be, but usually they are. We kind of group similar stuff together in arrays and non-similar stuff in objects. And that allows us, you don't have to do it that way, but usually that's what you do. Actually, yeah, you don't have to do that way. My voice is too low. Okay. Is that any better? Or like low in quality, like volume, or you're saying like my voice itself is low? All right, let me know if that's not good. The good old child's parable of Jacques is the JS squirrel, yes. Yeah, I think you don't have to put them all the same, but there's no reason not to. Usually with arrays, you always do. I could be wrong. We'll look at it in a second. A notation for getting at the elements inside of an array can also use square brackets. A pair of square brackets immediately after an expression with another. So here you're saying like we can reference the index here. And like they said in the intro that we looked at. All right, this is good now. Cool. This is zero base. So 0, 1, 2, 3, 4. Why? I'm sure there's a great history. I don't know. But it just is. So, and a lot of things, most programming languages are zero indexed. So 0, 1, 2, 3. So this right here should give us back this value, the third value. So we're going to grab the third item using this zero index. So you can do it like this, and you can see how here you can even do like math, I guess, inside here. I don't know why you'd want to do that. I'm sure there'd be some reasons, especially if you're interacting with the DOM, but so you can use these kind of bracket notation. Now you can actually do the same thing with objects as well. So here we looked at like student age, but I could come in here and say student, and I could say age like this. Now, the reason you want to do this with objects, which I'm sure we'll look at, is when there are values that have like spaces in them, which usually comes back like when you haven't defined the structure yourself, but you're getting it back from something else, or you want to pass in some dynamic value. Anything dynamic or anything in a string like this or with spaces has to be wrapped in this kind of bracket notation. But with arrays, that's the normal way of working with them. So let's go back to the normal way of working with objects, which is this dot notation. With arrays, you have to use the bracket notation, but you can use it actually with either. All right, zero index, we already looked at that. Okay, so let's look at some properties. We've seen a few expressions like myString.length. To get the length of a string, and max.math, the maximum function. We've already looked at these in the past chapters. If you weren't with us there, that's totally fine. But basically, there are items, properties that live on certain values. In this case, this was a string we created, and JavaScript does a few things already. So we don't have to write every little tiny micro item we want automatically. So it'll actually embed this in the language. One of these properties is the length. So if you write a string, it'll count up the values in it and give you a length for the number of items. It actually does the same thing for arrays and a couple other things as well. Let's see. Fuzzy says C++ was 0 index and JS was meant to be a DSL. Okay, there we go. Perfect. I knew there was some CS history behind it. So cool. Like most things, JavaScript is like kind of this hodgepodge of a lot of stuff that came before it. It wasn't ever supposed to be everything it is, but now it's everywhere. These expressions access a property of some value. In the first case, we access the length property of my string. The second, we grab max. We use the math object. And notice here we've got this max, and this is actually a method, right? So we've seen this before just a moment ago where we said, hey, there can be functions that live on these objects. Well, this math thing comes to us in JavaScript, and we can use this .max expression and pass it two values, and it gives us the bigger of the two values. So just so you can see what that is, if I say math, this comes as part of JavaScript .max. Notice this is a method, and VS Code actually gives me this little box, which tells me it's a method. That's their symbol for it, and I can pass it two values, 1 and 4 or whatever, and it's going to give me 4, the bigger of the two. Well, what are we doing here but passing arguments? And if I hover, you'll see that it's actually going to show me, hey, I accept an array of values, and several values here, and I pass back a number to you, which is what we want, right? So, okay, back over here. Almost all JavaScript values have properties. So the difference between a property and a value, you can see over here, our property and a method. A property is defined with this name, like name or age or class or whatever. These are properties. They're static values that come back to you. Whereas a function, a method, lives on an object, but it can give stuff back to you. So it's an actual full function. Whereas this is never going to change. It's always going to be math unless I change it. But when I call it, I'm expecting it to be static, right? All right, so the two ways to access properties in JavaScript are with the dot notation and the square brackets. Both value.x, so the dot notation, and value straight bracket x, access a property on value, but not necessarily the same property. The difference is in how x is interpreted. All right, they're going to get into some of the kind of distinctions of why you use one over the other. When using a dot, the word after the dot is the literal name of the property. All right, we just saw that. Student.age, right? That was the exact name. When using square brackets, the expression between the brackets is evaluated to get the property name. That's why you can pass in dynamic values. So let's say you're getting back something from some kind of API endpoint, which again, you may not know what that is if you're just getting started since this is beginner JavaScript, but you might get a value from somewhere else outside your program. And you don't know what that value really is. You just know you want to pass it through and pick it off an object. Use it to kind of pick the name off. So you pass that in, it gets evaluated, and then it checks the object. Do I have something like this? And turns out it does. I actually don't know if you can you evaluate a function name? I don't know. Let's figure it out. All right, so if I come back over here, we does stuff. What happens if I do this? Can I do this and then call it? No. Or I guess this would have to be in a string anyhow. Yeah, I guess you can do that. Okay, that makes sense. I just didn't know because you would never really do that. So I guess you could, but yeah, not usually. All right, they can be any string, but the dot notation works only with the names that look valid, like binding names starting with a letter or underscore containing only numbers, letters, or underscores. So the dot notation you can only use with like names you can actually assign to values. So you might remember a couple chapters ago, we defined like const num or let num equals whatever. Those had certain rules to them. Again, you don't have to memorize all those, but basically they can't be special keywords in JavaScript. They have to start with a string or a $sign or an underscore. They can contain numbers, but they can't start with a number. So those are the things that you can reference as dot notation. That's why we did student.age, right? We couldn't do student.134.6 or something, like we can't do that because it has to be a valid name. So for anything that's not a valid name, that's where you'd use the curly brackets, or anything that's dynamic. Like John Doe right here, you can see that it has a space. Well, you can't define a variable with a space, but it's possible that that is the name on an object. So I should mention that over here. These names, they have a little bit more flexibility. So I could say like a name of student like this, And this is valid. This is totally fine to do here. But notice it's in this string. To reference it then, I can't reference it with dot notation, but I can do it like this. It's not a method, but you see I can actually get that, I think. Name of student. Student, name of student. I think I can reference this. I'm not sure why it's not console logging. Console.log. Maybe it's because it's not in a console log. So we grab Chris. I can't do dot notation here. Name of student doesn't work. In fact, when I tried to do it, it actually wraps it, right, for me automatically. So it has to be a valid name to use dot notation. Okay, the elements in the array are stored as array properties using numbers as property names because you can't use the dot notation with numbers. You usually want to use a binding that holds the index anyway. You have to use the bracket notation to get them. Just like strings, arrays have length property that tells you how many elements are in an array. So again, JavaScript knows you probably want to know how many items are in your array. So it just counts that, it collects that for you automatically and attaches it to the actual object. So maybe we should talk a little bit about prototypes in a second here. Methods, we already looked at a couple times here, which is basically they are functions on an object. So just like we have properties on an object up here, we also have a function on an object, and that's all methods are, all right? Even though we call get up uppercase, do we need to know anything else here? Not really. So push is they're just showing you a new method that you can use to add values to the end of an array. Pop takes them off. We'll look at some of those in a second here. These somewhat silly names are traditional names for operating on a stack. A stack in programming is a data structure that allows you to push values into it and pop them out again on the opposite order. So that's why they're named that. Okay, so let's talk a little bit about prototypes before we do anything else. So I'm going to do this actually in the browser console because it'll be easier to show you. But if I come in here, well, I guess it's not necessarily easier to show you. Let's just do it here. Okay, because I'm already here. So we'll say like we have some kind of number. So const number. Okay, I guess I did that at some other time. Okay, so now if I go num dot, I'm going to have a bunch of stuff on here automatically. I haven't added any properties to this. So it's just a static value, right? So how do I have properties on here? I have constructor, then I have methods, to exponential, to fixed, to locale string, to precision, to value. Why do I have, this isn't an object. Why do I have methods? Why do I have like properties? Here I have a has on property. This is going to give me true or false. So that's a property. It's not a method. It's an actual fixed value. Is prototype of? Prototype is enumerable. Why do I have all this stuff? Well, that's because everything in JavaScript kind of is an object. In fact, there's another way to define a number that we haven't looked at least I don't think we have. So I could say const num2 equals, and I can use this number constructor and pass it a number. So I could pass it 2 or something like this. Now, this is ultimately what JavaScript does for us under the hood when you pass in just straight up number. It kind of does this for us so that you don't have to always wrap everything in number that's a number. But the same exact thing exists. So if I come over to num.2, you'll see I've got all the same things, toString, all this kind of stuff. So how is this happening? Why is this happening? Let me zoom in a bit here too. This is happening because JavaScript, everything kind of at the base is an object. We can see that if I say like my string, Chris, then my string, you'll notice, oops, if I can type string, there we go, dot, again, I've got all these things. I've got methods, I've got properties like the length of the string. All this is built on by default. Now, the reason this is built on is because, again, everything by default is an object in JavaScript. So I can come and say const my string 2. And now I'm going to use the string constructor where I'll pass it Chris. So this is, again, what JavaScript is doing for us. And I can take my string 2 down here. And again, I've got all the same things. So what's actually happening is it's getting all this stuff for me and attaching it when I create a new string or when I create a new number so that I don't have to figure out what is the length of the string. I can just type length because it's already attached that property. So I'm getting the value when I just use the name, my string 2 or whatever. However, I've got all these properties attached to it. So let's talk a little bit more kind of about, well, let's see what's going on under the hood. So we've looked at it with the dot notation, but I want to actually see what is there. So let's take console dot, what am I looking at? Dir. So there's a bunch of different consoles. We've only really looked at console.log so far, which is kind of the normal one, but I can pass in my string too, like this. Can't I do this? I was thinking I could get this back from console.dir. Maybe Fuzzy knows. I don't know if he's still here. I thought I could get this from the string object this way. I was just going to break down what's in here like a little bit more precisely, but maybe not. My string, what are my options again? I don't remember. Depth. No. Depth, infinity. You don't have to do this. Okay, I thought it would break down all those options. There is a way to do it, but I'm not thinking of it right now. So maybe they'll show us that. But just that to say, like, strings and numbers under the hood are actually objects, more or less, in JavaScript. Everything is an object in the end. Even functions are an object. So everything is an object in the end. So that's why we can do dot notation off of them. If you're like, wait a second, how can I take a number and do a dot and turn it to a string? That's because technically it kind of wraps it in this object. All right, maybe that's helpful. Maybe it's not at this stage in your journey, but objects are a big deal. That's all I'm trying to say. Oops. Okay, so back to War Squirrel, hard pass. Values of the object. I'm not sure what this is. I don't want to get into the whole lore of a squirrel right now. So I'm just going to stick to this and I'll explain it myself if that's cool. Values of the type of object are arbitrary collection of properties. So in other words, you don't know what's in them until you check. It's not like there's a fixed number. You can add them, you can remove them. So here, kind of like our student we did a second ago, we have day one where we take squirrel equals false and events. And look at this events. I have an array as the value for this this item right here of events, this property of events. So I can console log day one dot squirrel, right? This dot notation should pass back false. I can do day one dot wolf, and that does nothing. Why? Because there's nothing called wolf, right? So I can do day one dot wolf here equals false. And by doing it this way, I'm not console logging it. I'm actually assigning it. I've actually added this new thing to it, which means now it has it. So even though it's not visible here, I've added stuff to the object. So objects have flexibility. You can add things to them, remove them from them. Same thing over here. So we've got the student. I could come over here and say, hey, student, let's do like a student dot. And if it doesn't exist, so I could be like pizza, I can just assign this like pepperoni. And now it actually has this on top of it. So now I can come over here because I've added it right here. It now knows it has access to it. So if I come over here with pizza, it should say pepperoni, right? So I don't see it here, but I can add it to it. Now, you can already see how this can get really confusing. You have to be really like predictable in how you interact with objects. Otherwise, you can be thinking something's there and it's not. You often also have to check, does this property exist? I think it should, but maybe I removed it somewhere else in my program. So whenever you're removing things from objects or adding them to objects, you've got to be really careful to make sure that you know what you're kind of dealing with. Okay, inside the braces, you'll write a list of properties separated by commas. Each property, we've already looked at this, has a name followed by colon and a value. But remember, we took those lists of consts, like const name, student, class one, whatever, and we converted it into an object. And all it does is you take away the consts and you replace the equal signs with colons and then the semicolons with commas. All right, so it's just grouping these together, so there's a slightly different syntax. That means that braces have two meanings in JavaScript. At the start of the statement, they begin a block of statements. We've looked at that with like if statements or even functions themselves, like a function block. And any other position, they describe an object. So it can get kind of confusing. We'll talk at that in a second. One case where this does come up is where you want to return an object from a shorthand arrow function. All right, so let's look at this in case that's confusing. So let's come over here. We'll say like, say my name, all right? If this is an arrow function, this was the syntax for it. You might remember that this shortens the expression a little bit, allows us to do some cool stuff here. And we can write a function block like this as part of this arrow function. And I could say down here, return, I don't know, this is probably not a good example because I want to return an object. So we'll say like transform my name. All right, so we're going to take in a name here. And here I want to return something from here. And I want to return a whole object. I can do that. So this outer block defines the block. Any other time we use this curly bracket, it's defining an object. And again, we can also use an object like this, just like I saw with string. We saw with string and with number. So they're also, they're called constructors that you can use to do that as well. But usually you just define it the easiest way possible, right? So we could say like, whoever this is, like, is cool, all right? And they're always going to be true, but I want to take their name and I want to add it here, all right? So whatever name is, name that they passed in. This is kind of confusing the way that I've done this. So for now, I'll just say my name, all right? Because it's my name after all. So I'm going to return an object from this function, which I can totally do, right? So let's come over here. We're going to now grab, what is this thing called? Transform. My name, let's make this smaller. And I can pass in like Chris, all right? And here, let's use a method while we're at it. So I know that on strings, which is what this is, I can use two uppercase. Now notice it doesn't actually know it's a string, so it's not showing me that in IntelliSense. That's because we're not using TypeScript. Don't worry about it. But now what I can do is pass this back. And notice I've got is cool, true. My name is Chris. So I'm passing back, but it's an object. That's what I'm getting returned here. Now, again, this Quokka.js thing is super helpful for you when you're learning because you can kind of like, well, wherever you're at, because you can see values directly here. You don't have to always console log them, which is really nice. It also tells me these are functions that work. This is what this green item tells me. And you can win that by giving to the donation link listed below. All right. But over here, you can see how I'm returning an actual object. In an arrow function, let's say you're like, I don't want to write the return keyword. I remember we can do an implicit return. I'm just going to do that. And everything breaks. And that's because this is a function block. So if you want this to be returned, we're going to jump back over this way. Hey, awesome. Thanks so much for the comment. Glad it's been a help. If we want to actually return an entire thing, let's see if they show you here or not. Do they show you? No. You can't write it like that since the braces will be interrupted as the function body. You have to put a set of parentheses around the object to make it clear. This is not a function block. It's an actual implicitly returned item. If this doesn't make sense, don't worry about it. This is not important. You'll get around to it. Just know that like these symbols are used both for function blocks and for objects. Usually there's not confusion. This is basically the only time where you'll have confusion between the two. Here it's very clear. This is not a function, right? It's just values equals this. That's obviously a function. Here it's obviously an object. Here it's very clear. Oh, this is a function block. It says function, right? And then I have this stuff in the middle. This is clearly a function block. I could write a bunch of other stuff down here. But there are times where it is confusing. And that is when you want to return from an arrow function and you want to return an object. You can't just assume that it knows it's an object. It's going to assume that this is a function block because it looks like a function, right? But you're actually just returning something directly, implicitly returning it from an arrow function. So that's the only time they get kind of confusing. So we can return a function out of another function. Oh yeah, you can definitely do that. Yeah, functions can return anything. In fact, it's really nice sometimes to make a function that generates other functions. There also are generative functions. There's a lot of cool stuff you can do with those. But yeah, good question. Okay, reading a property that doesn't exist gives you undefined. We've already seen that. It's possible to assign a value to a property with the equal operator. So you can change stuff in objects as well. So like, let's say I want to change class 2. So let's come over here. We're going to take student.class1 is geography. Now I can say student.class1, and I'm not going to console log it. This time I'm going to assign it. We'll say like, I don't know, English or something. All right, and then I'm going to come down here and let's copy this. I'm like stuck halfway between Vim and, but I'm trying not to use Vim. But you'll notice here, first it's geography, now it's English. Well, what changed? In between the two, we changed it here. Again, objects are super helpful because they're so fluid and flexible. However, you've got to really make sure you know what's in there. And this can really mess you up if you're not careful. So you've got to be very predictable in how you interact with your objects. So you can assign them as well. You can define them if they don't exist immediately. So like, again, if I say class 3 here, class 1 is going to still be the same, but now I've got a class 3 suddenly on here that's English. So if they exist, you can override them just by using this equal sign. If they don't exist, you can just assign them and create them by using the equal sign. Again, right now, don't pay attention to all the syntax. It might be confusing, like when do I use an equal sign and when do I use this? Just think through the concepts more. Objects hold data. You can interact with that data by using the dot notation or the straight brackets. You can get data out of there. You can assign new items in there just by using the equal sign. You can override existing items just by using the equal sign. And there's not a lot of safety in that. So you got to be careful on how you do it. All right. KG Malik, the DOM. I'm guessing you're talking about the DOM. Maybe the document object model is what happens in a browser where it grabs all the items in these elements and it turns it into an object that I can interact with. So if I said DOM, that's what it was talking about. Okay, to briefly turn to our tentacle model bindings, property bindings are similar. They grasp values, so you give them a name and you can assign them to things. The delete operator cuts off a tentacle from an octopus. So here you can see how we can, let's see, are they going to say this somewhere? It's an operator that when applied to an object property will remove its name from the property. This is not common, but it is possible. Yeah, let's not worry about it. It's not that important. In binary, the binary in operator, when applied to an object in a string, tells you whether the object has its value. So now they're basically like listing out different things you can do with objects and with arrays. The difference between setting a property to undefined and actually deleting it. In this first case, the object still has the property, just doesn't have anything in it. Whereas in the second case, the property is no longer present and in will return false. All right, let's look at what they're telling us to do. So they're saying use the delete keyword, which is this is not normal. So that's why I was going to skip over it. But this removes the object. It's totally gone. Left in an object. It says, no, it's not. Right is still in an object. It still exists. That's all they're showing you. Okay. So you can use the in keyword to figure out if it still exists. And the reason they're saying in an object is that's what this is named. It could be pizza, and it would be pizza down here. Okay, you can use the object.keys to see what the values are, or the keys are, and then values to get the values. So let's come over here. So far, we've just been randomly console logging stuff. Let's take our student here. This is an object, right? This whole thing is an object. And if I hover over it, it tells me the types of things in here because TypeScript is kind of doing some magic in VS Code here for me. But I could say object dot keys, and I pass it an object like student. And now it's going to give me an array of all the names of the properties or methods connected to this object. I've also got other things like values, and it's going to give me all the values. Again, you don't have to remember all these details. You'll get to understand these. Just note that there are things you can pick off of an object that kind of give you a chance to see what's in there, right? So I might want the values. I might want the keys. There's other things you want here as well. So again, I've got all these things attached to kind of the prototype of the object itself, the defined object in JavaScript. Again, we'll get to more of that later. Values we've looked at, toString, name, length. So I've also got a length in JavaScript or in object. Oops. I think I have to actually take the object like this, dot length, maybe. Undefined. No, yeah, it doesn't have one. Sorry, that's just an array. Okay, do hackers also use JavaScript because it's a programming language? Yeah, they can use. I mean, it probably depends on how much you want to talk about, like what it means to be a hacker. But yeah, like a lot of you can manipulate. Like sometimes they'll say like, you'll see in some consoles, if you open them up, they'll say, don't paste anything you got from online in here. If somebody told you to do that, that's because you can give somebody some JavaScript and say, hey, open up your console like this and paste this JavaScript in here, but it'll actually run it and it could pass along secrets or money or whatever else. So that's one thing you can do. You can also inject JavaScript into a page with cross-site scripting. So anyhow, it's basically, yeah, you can do bad stuff with JavaScript. But it kind of depends on what you're hacking, right? You need whatever language it is that you're hacking. Okay, there is an object.assign function that copies all properties from one object to another. So we assign object A to object B or whatever it happens to be. So now we have a new object. Arrays then are just a kind of object specialized for storing sequences of things. You can evaluate type of array and it produces object. Like I said, everything is kind of an object in the end. I don't think this is super important to know right now. Let's look here. We're going to see we've got an array, but this array has objects inside of it, right? So it's an array of objects. Now, why would you want this? Well, let's imagine, again, we've got our student, and maybe instead of calling it student, I'm just going to call this Chris. Why am I putting this in strings like this? So this is Chris. He has all this stuff in here. I don't need a name because now this is what the object is called. And I might also have other things. So let's say I have like John is another student, and I want to take both of these and kind of combine them. So let's get rid of this. So I might have a students array, right? Arrays hold common things. And here I'm going to have both Chris and I'm going to have John, right? These are both of my students. So if I look at students here, notice it's giving me both of these things. If I console log them like this, students, you'll notice I get all this stuff here, right? Age, whatever, all this stuff. So I'm getting all these items. These are these objects inside of here, right? So they contain all this data. And that might be a time in which you basically have objects being passed in or kind of referenced in an array. There's other things you do as well. And you may not have them defined like this. So this would be defining them outside of the array. You could also define them inside of the array, which is what they're showing up top or in the other example. So I could come over here and I could just paste it directly in here. Oops, I couldn't remember if I copied that or not. In this case, though, I would need some kind of name on here like Chris, right? And so this now is defining the object directly in here, which works as well. And then the second one might be John. And maybe John is like, I don't know, 14. Okay, so now if I come down here, I can come into my students and I can pick off an individual item there. But notice I don't have any dot notation because I'm inside of an array. How do we do that? Well, we do it with this bracket notation. And it's 0 index, so I can grab the first person. Then I can use dot notation and say, give me their age or give me their name, all right? And it's Chris. So it's going to come in here, grab the first item in the array because I'm using 0 index, and then I can use dot notation to pick off the age because I'm inside of an object at that point. So you can have arrays that hold objects, objects that hold arrays. You can be very flexible with this data structure. And notice in this case, this is an object that has one property with another array inside of here, right? And then, I guess it has two properties. It also has squirrel equals false, squirrel equals false, squirrel equals true. I'm sure if I had read their Jacques story, that would have helped. All right, we probably need to hurry because I said I didn't have much time and then I'm just talking. How's it showing methods options after dot in any type of extension? Is it any type of extension? No, in VS Code, it gives you this automatically. Most environments will. It shows you kind of what exists on that item you're looking at. Okay, so let's speed up. I've already talked about a lot of this, so hopefully that will help us. We'll get into actual programming soon, but first there's one more piece of theory to understand. We saw that values can be modified. This is called mutability, and this is where you can get really dangerous, all right? The types of values discussed in the earlier chapters, such as strings, numbers, and booleans, are all immutable. It's impossible to change those types of values. You can combine them, but you can't change the actual values. Now, this gets a little confusing, but this is the difference between referencing a value and not. So let's see if it talks to this, and I'll let it do it first. All right. So the text inside cannot be changed. If you have a string that contains cat, it's not possible for another code to change a character in your string to spell rat. All right. Objects work differently. You can change their properties, causing a single object value to have different content at different times. When we have two numbers, like 120 and 120, we can consider them precisely the same number, whether or not they refer to the same physical bits. You might remember that anytime you're referencing something, JavaScript stores that in memory somewhere. And so these would point to different values. So let's look at TLDraw. We've looked at this before, so looks like I was doing something like this last time. So let's say you have in memory here, we've got this little space here. Oops. Get out of here. Let's just get rid of all this. All right. Let's say that this is like this spot in your memory. And this little spot in memory is going to hold the value like 120. All right. Now we can duplicate this and have another spot in memory that's called that's 120. How would we reference these? Well, we'd give them some kind of binding, some kind of name. So like the way this looks in JavaScript is like const, like my num equals like 120. Well, this equals sign is just pointing the value to the spot in memory. So I can say like this, my num equals whatever, right? Same thing over here. This would be like my num2. I can't have the same things named. Even though they reference the same internal value, they're totally separate, right? They're separate entities inside of JavaScript. And so in order to change this, I'd actually rebind this. I can't do it with const. I'd have to do it with like a let. But it would actually basically get rid of this completely And let's say I named it to like 60 and have another spot in memory, or 50, I guess, since I can't type, where it's now referencing this one. So you can change like a let variable, but it's going to actually reference a different spot in memory. That's not the same with objects. Objects actually reference the singular spot in memory, and you can change them even with a const. So you might remember, if you've paid attention in the last couple lessons or know this much about JavaScript, usually with const and these kind of base values, these root values of like numbers and strings and booleans, you can't actually change them with const. It's like a protection against that. You can with objects, and that's because they reference the same spot in memory. So let's say this object here, it has like name equals Chris, and age is like, I don't know, 12, whatever. All right, so this spot in memory is, we're going to say like person 1. All right, so person 1 here, but I can come along like we just saw a second ago, and I can just add stuff to it. So I could say person 1 dot like pizza equals like pepperoni, right, or whatever. This needs to be in a string, but you get the idea. All right, that will actually go back to memory and say, hey, let's store another thing in here, and that would be pizza, and this would be equal to pep, right, which is my string here. Okay, so this should technically be in a string too. Not to get all technical here, since this is just DLDraw, but so now it's referencing this. Now I can actually just totally change what's here, or I could just let's say get rid of all this stuff. It'll actually come back into the same spot in memory and can kind of clean that up. So anyhow, hopefully that helps to kind of, that's a very basic understanding. Hopefully I'm not confusing something technical. All right, with objects, there's a difference between having two references to the same object and having two different objects that contain the same properties. So I think we can use the example we just did in a second to look at this. So we've got object 1 that has value 10 in it. I can say let object 2 equal value 1. You might think it's going to duplicate that, create a separate copy of it, but that's not what actually happens. I can say object 3 value equals 10. So we've got 3 objects. Right now, they all should have value equals 10, right? So if I come in here and I say, does object 1 equal object 2? Yes, it does loosely. Is it the exact same thing as object 3? Or does it equal object 3? No. Why is that? You might remember we can use this double equal sign to check if they're the same value. Here it's actually saying, this tells us these are pointing to the same spots in memory because we just assigned object 2 to object 1. So before we look at their finished example, let's say we have these two things. We'll come over here, and what was their example? Value 10. Okay. So let's say we have value is 10. Like that. Okay. So here's object 1. Over here we have object 2. And so this is called const object 1, right? Now if I come over here and I say, let's define a new one, const object 2, and this is going to be equal to, and I'm assigning it, which means I'm using one equal sign to object 1. All it's going to do is going to point a reference to the same spot in memory. So it's a new name, but it actually references the exact same spot in memory. Now over here, I said const object 3. So this is its own little section right here, and it's pointing to this section in memory. So when I do a comparison like we saw a second ago, and I say, hey, is object 1 the same as object 2? It says, yep, they're the exact same because they both point to the same spot in memory. Even though object 3 and object 1 contain the same values, because they point to different sections of memory, it says, no, they're not the same. Now, here's where it gets real tricky. Object 1 dot value equals 15. Okay, so we've come in here. We've come in here. And what have we done but say value in object 1 equals 15. Can you see where this is getting tricky? Let's console log object 2 dot value. I haven't changed anything with object 2, but I get back 15. Why? Well, it's because of what we just saw, right? The memory. Object 2 still points to the same spot in memory. So when you assign it like that, by setting this equal to this, you're not making a copy of it. You're pointing to the same spot in memory. So this is the difference in a referenced value. So object 1 and object 2 bindings grasp the same object. They point to the same spot in memory, which is why changing object 1 also changes the value of object 2. They're said to have the same identity. The binding object 3 points to a different object, which initially contains the same properties. It just happens to, but it's not the same thing, right? So bindings can be changeable or constant, but this is separate from the way their values behave. Even though number values don't change, you can use a let binding to keep track of changing the number by changing the value at which the binding points. So we saw that a second ago. With numbers, it actually like gets rid of the old one and creates a new value when you use that let and change it around. It doesn't do that with objects. All right, objects kind of live until they're destroyed by JavaScript, until they're garbage collected. Similarly, though a const binding to an object can itself not be changed and will continue to point at the same object, the contents of that object might change. All right, so normally you can't change a const variable. With objects and arrays, you can, because all they're doing is pointing to a spot in memory. So you can change what's in that memory, but you can't change the spot they're pointing to. So actually, maybe let's demonstrate that real quick. Man, I said I was going to speed up. What is my problem? We might just have to finish this chapter later. There's a lot with objects and arrays, if you can't tell. But let's say we have another little spot in memory. And I'm going to come over here. All right, so let's say this holds a number, all right, like number 1 right here. And I'm going to grab this. We're going to pull this over. We're going to say my num again. Now, this is a number. Normally, when you use a const, you cannot point it, change it, right? So I couldn't come in later here, and I couldn't say, I don't know why I'm copying and pasting these, but I can't say like, now I want to take my num, and now I want to assign it to 2 or something like that. I cannot do that because it's pointing to one spot in memory, all right? So you can't change this value here because it's a primitive, a number, a Boolean, or a string. So I can use let here, like we saw a moment ago, let my num equals 2, and now I can reassign it, but what it will do is destroy this spot in memory, and it's going to create a new one with the value of 2, and now it's going to point this to here, like we saw a second ago. Now, when you come in here and you change the constant, you can change a constant, like object 1, we changed the value to 3 because it's still pointing to the same spot in memory, and it's referencing that spot instead of holding that, grasping the individual primitive value. Hopefully that makes sense. Hopefully that's clear. So basically, Booleans, numbers, and strings act differently than objects and arrays here. Objects and arrays allow you to change their values in the same spot in memory. Booleans, numbers, and strings are primitives. They don't. So they'll actually, you have to use a let to change it at all, and then it basically will get rid of that old binding and redefine another spot in memory. At least that's my understanding of it, not being a CS person. When you compare objects in JavaScript, the double equal operator, it compares by identity. It'll produce true only if both objects are precisely the same value. Comparing different objects will return false, so we already saw that. There's no deep comparison, so it won't look inside it and ask like, does this object contain all the same values as this object? It's not asking that. It's just asking, are they pointing to the same spot in memory? All right. Man, now we got extra stuff. Should I just kill this now? Because I think we've already gone through a lot of this. But now we're getting into like computing stuff. I think this is going to be confusing if I try to jump into the rest of this. Hopefully you have a general sense of how objects, how arrays work, how they work in reference to memory and that kind of stuff. I do see a question here, so let me answer that first. I want to become MERN freelancer. I created an account on Fiverr, Upwork, Freelance Guru. Now I'm learning JavaScript. What's the next step? I would say until you can, I would say focus on HTML if you're looking at the MERN stack, which honestly is a little bit of an older stack, so it's not like it's a problem, but you probably want to be thinking more general right now. HTML, CSS, JavaScript, no frameworks. That's how my preference is. That's how I learned. Not that you have to do it the way I did, but hopefully that's helpful advice. So yeah, I would just stick with those three. HTML and CSS, I wouldn't move to JavaScript until you're pretty confident in that. One of the best ways to test yourself is just to find a website you like. Maybe start with a basic one and say, can I duplicate this site? So download all their images from that web page. Make sure you get access to their fonts and see, can I duplicate this one for one exactly without looking at their code? That will tell you, okay, I'm confident enough. So I remember I practiced like on ESPN. I would just like go on ESPN and like download a page, an article and say like, can I duplicate this whole layout? Maybe just Yeah, I do that a lot. I've done that a lot in my live streams in the past. I just find a site and like, oh, let's make this in Astra or in whatever I'm using. So HTML, CSS, make sure you're confident there. Then I would go into JavaScript. Make sure you're confident enough to understand all the core functionality here. We haven't even really looked at what methods are available here on objects or on arrays or those kinds of things. So eventually you want to be able to like take items and for every item in an object, do something to it, or every item in an array to do something to it. Those are methods that are built into the language. So I'd be really confident with JavaScript. And once you're confident with all that, then you can move on and learn React or Tailwind or something else like that, other frameworks. So hopefully that's helpful advice. Okay, let me remind you before I close out here that what am I looking at? Oh yeah, this fundraiser right here. I can't remember. Maybe somebody actually already did something during this stream, but I'm raising funds for St. Jude Children's Research Hospital. They are in a huge push. They actually just started this year to get actual cancer medicine to countries all over the globe, to children who don't have access. 80% of children with cancer worldwide do not survive. In the US, that's flipped. 80% of children do survive. That's in large part to the work of St. Jude. Now, they don't just treat people in the US, they treat people everywhere. And if you want a full deep dive in what it's like to be a patient there, I just did a really special interview for me yesterday on my channel with Stephen Hackett, who is kind of spearheading this particular fundraiser that I've kind of latched onto the last 4 years. But what they're trying to do is basically take their not just their research and their knowledge, which they've already shared all over the globe. They're constantly in talks with doctors all over the globe saying, oh, we're specialists here. Even though I'm not in, wherever, England or whatever, I'm going to call that doctor. We'll get on a call. We'll talk through it. And it's very possible if you've ever known a child who's been treated with for cancer anywhere in the globe, they have directly benefited from the actual knowledge of St. Jude in the moment. But even if they haven't, the research that they provide is free and they pass it all around. And you can participate by just giving $5 even. And I've got so many things to give away from Vercel and Cloud Cannon, Mux and V0 and Neon, not V0, I looked at Vercel. All of these, I've got stuff to give away. You can see all the details down here, but I don't have enough people to give it to right now. So if you just give $5, you're basically going to win one of these things because it ends on Tuesday. And then next Friday, I will pass these out to people. So let me encourage you to give, to be generous. You all always have been, but please give by this time. And then I will kind of calculate all that, make sure you send me your receipt so I know you gave, and you'll get raffle drawings. And you can even opt out of prizes if you don't want to win them. So anyhow, I'd love to have you join me. And if you want to know more about St. Jude, see the video I posted yesterday. Okay, well, cheers. Thanks so much for following along today. I hope that was useful. I know we had a bit of a rough start. I think maybe I finally got my audio stuff worked out. But I hope you have a great day, and I will catch you Monday where we'll finish chapter 4. Promise.